Let there be light. All right, thanks for tuning in today. Today, I'm going to go through and I'm going to showcase my automatic blinds. These are a complete DIY solution. Everything is hardwired. No batteries to change. It's fairly quiet. I have the mic on me. So compared to other options, it's pretty darn quiet. Now, why I kind of jumped into this is years ago, the first option that was out there, the only option that was out there, I think, was my smart blinds or tilt my blinds. They were showcasing for like $100 a piece. I think it went up to $150 a piece per blind. Now, these are retrofit kits that you install into the enclosure of your blinds themselves. So you utilize existing blinds. That is expensive. I had 4 of them. I had them in these 4 windows. I had it for about a year. Once every 2-3 weeks, I had to pull out a 20-foot cord, charge each blind. They're Bluetooth operated, didn't integrate into the smart home and whatnot. You know what? After a year and a half, I said enough is enough. Ended up selling those 4 units on eBay. Turned around, took that money, kind of invested into myself. Stepper motors, different stepper drivers, different things just to play around with it and try to find a solution that worked for me. Bring me to today's solution. All said and done for about 4 blinds. I get about $70 into it for 4 blinds. Now I can control with my unit, my board, I can control up to 4 blinds at once. Or I'm sorry, 4 blinds with the PCB, the setup I have, 4 blinds at the time, 2 separate groups. So window 1 and window 2 are tied in a group, window 3 and window 4. So I can't control all 4 independently, just left group, right group. Alexa, open the west blinds. She didn't hear me. Alexa, open the west blinds. Alexa, open the north blinds. Alexa, close the living room blinds. So we kind of fast forward to today. Kitchen, every bedroom in the house, every window in my house has an automated blind. All right, please join me. Before I forget, today's video wouldn't be possible without the support and help from PCBWay.com. Please check them out. They offer multiple different PCB design, assembly, manufacturing services, along with 3D printing and CNC services as well. Please go check them out. Let's go ahead and jump into today's project. There you go. Get this coffee out of the way. All right, so we're going to be looking at the blinds today. We're going to be going through the software side of it, installing Tasmota, along with some of the hardware side of this as well. So this is a 3D printed enclosure that holds PCB that I've created. When you remove the cover, it gives you access to the ESP8622, along with 2 mounting holes. Screw this to a closet, shelf, wherever you would like. There's a hole for the LED indicator. This is 12 volts coming from a benchtop power supply. While one motor is moving, I read 0.3 amps, so not much at all. 2 amp power supply is more than sufficient for 2 of these units. I do have a second one here. This is outside of enclosure. I do want to show the fact that I do have an RJ45 on the back of this. The purpose of that RJ45 is so you can have one power supply, and I even tested this with a PoE injector, putting 12 volts in here from a PoE injector 350 feet away. So you bring one 12 volt power supply into this, and you can daisy chain 2 units, power up 2 units off the one 12 volt source. So let me get rid of that. Go back to here. So we're going to jump into the software and, like I said, even the hardware side of this. I have made a few modifications. I did change the housing here. I'm actually going to change all my personal ones out to this one as well. It's a little bit smaller, a little bit more compact. The barrel here that actually connects to the stepper motor has a little flare on it. and with this top screwed in place, it prevents that from actually pulling off. So it just holds everything together a little bit tighter, makes it a little bit more robust. Now, a lot of the ones I have in place, I haven't had any issue for 3, 4 years, 5 years that they've been installed for some of them. So fairly simple under the hood. Now, I do want to state with these motors, we do need to change it from, I could be doing this backwards, but bipolar to unipolar or vice versa. So we do actually have to pull off the cap, and there's a center trace here. And it does go in detail in some of the documentation, but you just have to basically nick that center trace to break it. At that point, slide it into 3D printed enclosure. And screw the top back in. I've designed this to, nothing's tight. There's just enough throw in there. So you're not getting plastic on plastic, but it's not going to come off. So I do want to take this opportunity. I will throw up a photo someplace. But first time I ever did this project, it was a proof of concept. At that point, had yet to design any PCBs. I haven't dealt with any PCBs prior to that. Went ahead and jumped into this project, wired everything together, and I know it looks very simple this way, but there's actually quite a bit of internal wiring between bringing 12 volts out to the motor, 5 and 12 volts out to the motor driver, communication between the motor driver and the ESP8622. There's quite a bit going on there. So I had everything wired up in a small package. I will throw up a photo somewhere in here. It was ugly. It was ugly, very unreliable. I can't tell you the amount of frustration I had getting up on a stool while these were in place, trying to repair broken wires and burn out buck converters and burn out chips in that whole process, just because everything was stuck together in a tight little package and everything was touching and shorting out. It was a nightmare. That was the first project that I ever jumped into, actually designing the PCB. First time going at it, it was a success. Very happy with it. I haven't turned back. I have probably at this point done 20, 30 plus projects with PCBs. Taking your projects from being just wired together, even on a breadboard sometime, and taking it to the PCB, that's a game changer. So absolutely recommend it. Absolutely. Oh, functionality of this real quick. So at the top, it's hard to see, but it does say power. It says W1, W2, W3, W4. You have window 1 and 2. These are tied together, and then window 3 and 4, these are tied together. So if I had 4 motors right here, the software side gives me control over 2 groups. So first group is window 1 and 2. Second group is window 3 and 4. So you can control up to 4. You can control up to 4 blinds per board, but only 2 sets independently, if that makes any sense. All right, let's jump into this. If you haven't liked or subscribed now, please do so. Even if you leave a comment, that would absolutely help. At the moment, I'm just doing this for fun, but I'd like to see where it goes, so thank you very much. All right, I want to jump into the software side of this. First, we are going to go ahead and install Tasmota. So I will provide the link below. I'm going to simply take my Wemos D1 Mini, and this is an ESP8266. I'm going to plug it into my computer. Go ahead and hit connect. Now, if you're unsure of what port, you notice I have 1, 11, and 5. Unplug this, and 11 disappeared. So I'm going to hit connect. Then we're going to install Tasmota. Takes longer than we'd like it to. All right, we're going to go ahead and hit next. It's going to scan for the network. Let me go ahead and enter my network credentials. See what happens. All right, let's go ahead and hit visit device. All right, put this off to the side for a moment. Close this. Now, as far as this GitHub, this is not mine, so I can't take credit for any of the software moving forward. This was amazing work. You know, I would suggest, I'll put this link in there, I suggest go visit them, give them a cup of coffee. All right, so we already looked at the hardware side. We're going to go ahead and scroll down, and there are multiple different options in here. Or scroll down to this one, which is where the hardware is built. All right, so what we do want to do is come in here and hit configuration, configure module. We're going to go to generic. Actually, let's see if we have our Wemos. There we go. Module, you're going to want generic 18. It's going to be all the way at the bottom. Then we're going to come in here and adjust this for the hardware. PWM 1. It's going to be none. It's going to be counter 1, none, then relay. It's going to be relay 2. It's going to be relay I. And that'll be 1. D6 is going to be relay 4. D7, PWM 2. D5 will be relay I 3. D8 is counter 2. And then none, none. Let's go ahead and hit save. Right, we're going to validate the Wi-Fi should be good. I'm just going to run through some of these. All right, let me disconnect from the network real quick. All right, so we have Wi-Fi. We have our MQTT. Now, yes, I'm showing you this is my internal IP. It's not going to hurt anything. This is going to be the username and password of your MQTT. All right, this is where we're going to put our topic test window. Oh, you know what? IHA window. Hit save. Configuration. Let's go to other. We're going to come here, device name, and
This is kind of what it will appear on your home network and whatnot. Friendly name. All right. All right, now we should be good to start making some little changes here. All right. This is the one that we're looking to use. We want to run through this, so we're going to enable shutter support. Go console, hit enter, enable shutter mode. Make sure it's important you get the whole thing. And then we want to restart it. Let's check my settings. I do believe shutter frequency 2000. So we're going to stick with this. We might make adjustments on the fly. I think we're going to stick with this. Right. Shutter delay. Now this is when you send a command, how long it actually takes for that to happen. So I'm going to put 1 second. So if you notice, we do have shutter motor delay 1 and then 1. What that's in reference to at this point now is the second shutter. So while I do this, I'm going to copy this, hit enter, come back, change this to shutter 2. 2 birds with 1 stone. Then this is when you first start off, I would make this relatively somewhere around like 0.4, maybe less. I would start somewhere around here. But for this, just for this purposes, we'll keep it the 15. Once again, I'm gonna copy it, paste again, come here, and I'm gonna change this to close. And what this is how long the motor is going to close for, which if we're doing blinds, it should be under 800 milliseconds. Let's see. We do want to do. Let's see. We want to make sure when that's done, we do a restart. All right. Now, if we go up to the top of this, however, and to this point, keep in mind we do need Homeassistant for this. So there are a few different options here. This is for a double. So we're going to go ahead and we're going to copy this. Oh, you know, come up here. I'm going to go into. All right, we want to go into Homeassistant. And this is actually MQTT, I believe, at this point. Yep. So let's take, once again, Now, I already have covers here. So I'm going to get rid of that. Stick with blind 1. So if you notice where it says living room blinds, this is where I believe I put IHA test. Let me find it. Main menu. IHA window. Alright, so it needs to be the same. Run through here. Alright. I'm going to go ahead and restart my Home Assistant. Alright, we're going to end up jumping over to, well, back over to the hardware side. See you in a moment. Alright, I figured I'd go ahead and speed up this process. It's kind of a long, tedious process. Now, if it's something you'd like to see more of, please let me know. Now, I did have a little bit of a hard time just placement of the camera. I have kind of poor vision, so typically I do a better job than this, just trying to work around the camera. So overall, it's a fairly simple design. I have a 12-volt DC power jack. From there, it goes into a buck converter that drops the 12 volts down to 5 volts. 5 volts goes into a regulator, drops down to 3.3 volts for the ESP8622. There is a 5 volt that is passed downstream to the motor driver at the end, along with 12 volts. So the Ethernet cable is providing 12 volts and 5 volts at the end, along with communication between the stepper driver and the ESP8622. I do have some directional diodes on here, along with a resettable 12 volt fuse and 5 volt fuse. Just wanted to make sure there's no issue. Now, there is an RJ45 on the back of this. The purpose of the RJ45 is so you can daisy chain modules together, up to 2 modules per 12 volt source. 12 volts, 2 amps is perfect. I hope you enjoy this process.